All right, we have two more talks. This next talk is by Jonathan Cran, also known as J Cran on Twitter. It's for all of you out there who enjoy the process of recon. This talk is called Scaling Up, Automated Attack Surface Discovery with Intrigue Core. So if you have watched one of my Sunday interviews with the gentleman, we actually talked about Intrigue, and it was, the gentleman talked about how he uses Intrigue to manage his recon. So let's give it up for Jonathan Cran, and let's get right into it.
Hey everybody, I'm super excited to be here. My name's Jonathan, and this is the first NahamCon. And so thank you very much for the invite. Today I'm going to talk to you about automated attack surface discovery with Intrigue Core, scaling up. So let's get into it. As I mentioned, Jonathan is my name, and I go by J Cran. Everybody calls me J Cran. I'm currently head of research at Kenna Security, which does risk-based vulnerability management, and I'm also the founder of Intrigue.io, which does attack surface monitoring for about 100,000 companies on a regular basis. And formerly Bug Crowd, Rapid7, and Pony Express. And so, the kind of thought behind this talk is that there is a lot of attack surface out there. And as researchers and testers, it's up to us to kind of scale to the challenge. And the challenge isn't getting smaller, it's getting much bigger more quickly, especially with the recent changes. The attack surface is just growing pretty rapidly. And so, this is a good reminder of there's a lot more stuff getting built than there is people to look at it, especially as regularly as it needs to look at. And so I like to start with Intrigue Ident, which is our fingerprinting library. And the reason I like to start with it is because it's a component of the overall ecosystem, but it's a good way to really understand the capabilities and the power. And so what is it? Ident is an application and network fingerprinting library. It has over 700 unique fingerprints for software in it. That software is specifically built to be, or those fingerprints are specifically built to be mappable to CVEs. And with the integration of Recog recently, that significantly bumped the number of checks up to almost 5,000 now. And so, traditionally it's been on the application side, but more recently Telnet, SSH, and these other network protocols. So you can see on the right-hand side the different things that we can use to fingerprint. And these are kind of very recently being added to, and there's quite a lot of activity around this. And so it's a good way to kind of show what's possible. So I'll just show you a quick check. And in this case, this is a check for Acme Micro HTTPD, which I think is an IoT type web server. And you can see the match type says it's using the content headers so headers basically to look for a server header. Match content is really the regex that matters here. So it's looking for a server header, Micro HTTPD. And it's looking for it, if you look at the paths attribute near the bottom, it's looking at the base URL. Inference is turned off, so we won't try to find vulnerabilities on this. It is not specific enough. And so ultimately, this is a very simple check. It looks, when it finds that particular server header, will tell us that that was Acme Micro HTTPD and that it's a web server. Now, simple check, contrast that with a relatively complicated check. This one's for Microsoft Exchange. And so in this case, we're using the dynamic version grabber features, the dynamic update grabber features of ident to go out and find a specific string, in this case from Outlook Web Access, and convert that. You see that OA to Exchange version, convert that into the actual Exchange version. So it can get very complicated in order to give you information about what the underlying system is. And this is an example of kind of the power. So in this case, we first match on X OA version, but then from there turned that into an Exchange version. So it's kind of inference upon inference. And so you can actually try this out today. All you have to do is run this single command, docker run it intrigue ident, and then just pass it a URL. And this will give you the fingerprint itself. It'll give you some metadata around it, the CPE, tags. If there are vulnerabilities and you pass the vulnerabilities command line argument, it will give those to you as well. You can actually get JSON outputs, and if you want just a list of all the vulnerabilities, give you a list. And again, a key and core feature of this particular capability and library is that it's fast. It will run those checks against a single URL. in order to be very, very quick. And so this is a key component of our ability to scale. Not the only thing, but a necessary condition, not a sufficient one. So Intrigue Core is the engine that ident folds into. So let's expand our scope a little bit in terms of what we're talking about and dig into what is Intrigue Core. Well, it is the core engine behind Intrigue.io, so it's powering data collection for 100,000 companies. It's quite scalable. We distribute this this core version, open license. Anybody can play with it. Anybody can use it. It's distributed via Docker, and so that you can see on the right-hand side that Docker command line to get you started, and I'll talk you through that in just a moment. And it's a scriptable engine, and it's really designed to do automation and attack surface discovery. It's kind of an orchestration engine. The command on the right, you can actually just directly copy and paste. A couple things to point out. That -v option is for Docker. It gives you a volume on your local system, in this case in your home directory, Intrigue Core data, maps that to /data in the container, which gives you the ability to preserve data across different runs. And the -p option will map your local 7777 port to the container, which will give you the ability to see the web interface and interact with the system. And so, you know, we can bore you with slides all day, but I find it's best to just give you a super quick demo. So let's just do that. And so we start out here on the project page. We can create a project. Netflix is a good example. So let's just put them in. And actually all those different tasks and capabilities are here. We're going to give it, to start with, a domain. Put in netflix.com. And go ahead and create an entity. And so it does that. And it gets a little bit of information here around that. And you'll notice, you know, we just put in that domain, but actually it came back and enriched that and came back with a bunch of information. Now you can iterate here. And let's say we want a subdomain brute force. Give you a bunch of different options. Use a file. And you can just keep going like this. And so it runs, doing its thing, threaded out, checking about 5,000 subdomains. And so we'll just let it do that and come back to that in a moment. So, you know, if there's all these capabilities here, what are they? There's things like web spidering. We mentioned fingerprinting already. This web interface that you just saw also has an API. It can automatically grab web screenshots, give you notifications, alerts, check for exposures, cross-reference with threat data, tell you whether a cloud provider is there or not. And ultimately, it's meant to be kind of an integration engine. All right, so what are the types of entities that Core cares about? Well, it's things that matter to testers. So that can be things like an application, what we call a URI, things like subdomains, what we call a DNS record, or just domains, phone number. Phone number is a little less common, but they're found on web pages, things like that. We'll parse them out. We'll create entities around them. GitHub accounts, network services being things like SMTP or FTP. And so these are really real world things that can be pushed into a task. You know, they're loaded into a task. The task runs and creates more entities. And so this is kind of a set of concerns. They're simple to create. They're effectively just a regex and some metadata. And so, you know, those entities are loaded into tasks in the form of nmap scan, mass scan, things like URI screenshot, which will take a screenshot of a web page, enumerating WordPress plugins, harvesting emails, harvesting phone numbers. This is, you know, there's a bunch of different techniques that can be used to grab information about an organization, and that's really what tasks do. It can be content discovery, so things like brute forcing directories, discovering known information leaks. In the case of URI brute focus content, that's a particularly useful one. So yeah, these are the capabilities that can generate more entities. And in fact, there's lots of different data set integrations like Shodan, Census, Binary Edge, Security Trails, and quite a few others that you know, provide useful information to a researcher and attacker trying to enumerate the the attack surface of a given organization. And so, with these capabilities in mind, how can we scale up, rather than doing this manually and rather than building a bunch of different automation each individually, are there ways we can kind of string these things together? And that's really what Intrigue Core was built to do. And so our required condition, though, is scoping. And so there's some automated scoping that's built in. It's rule-based, so basically anything the user scopes in or anything explicitly requested to be scoped will be discovered. And then on a per entity basis, it kind of makes a guess about whether it thinks that should be scoped in and discovered. And so these scoping rules, combined with the tasks and combined with the entities, and now combined with what we call machines, which are these automation units that kind of enable these decisions of whether to try more things. They're recursive, so they kind of build this graph of an organization. They're either active or passive, and they're designed with this sort of organizational collection purpose in mind in general, though they can be designed for other things like SSL, or specifically SSL certificate grabbing, or maybe just specifically scanning network ranges. Machines are very flexible. And an example is here on the right-hand side, where you give it a domain, and it tries to subdomain brute force that, and then it checks project sonar, which is a good set of subdomains. So as it finds those, it'll create DNS records, and those things will be iterated upon. And for example, when an IP address comes into the system, either automatically or from the user, we'll try to nmap scan it. And with the network service, we'll grab the banner and try to fingerprint. So, these features put together, combined with that enrichment that we talked about as we loaded in an entity with the create entity function, which effectively ensures that we can automate and build upon the entity. It lets us build automation without overwhelming complexity. And once we do that, and we combine it with that fingerprinting function at the beginning that I mentioned, ident, this gives us really quite a powerful capability. So let's just do a quick demo of that. Okay, so going back into the engine, we're back here on the dashboard page. You'll see there's again a few preloaded. Let's go ahead and create a new one. And project names don't really matter so much. It's all about the seeds that get entered. And so we're going to create an entity and create a domain. In this case, let's give it Tesla. So that's a good one. And in this case, we're actually going to start a machine. Considerations. This external discovery is usually a good place to start when you're doing this sort of thing. And so you'll notice it creates that entity. And here we go again. We're loading it up. And so based on the scoping rules, these IP addresses are pretty much always scoped in. So even though these are mimecast, we're going to go ahead and say yes, that's part of Tesla, at least for our purposes. SendGrid. And you can see a little bit of the information here in terms of like what the services that are being used are. And we got some system information. So I'm just kind of showing you a few of the analysis views. Which networks are these on? What are the system names? What are the IP addresses? Which countries? We don't have any issues yet. And so these are the results, meaning these are the things that are actually getting run. And each one of those has a log associated with it. So that information's all there. And so we'll just give it a moment to build this out. Now, in the meantime, you can see that there's some analysis features here. I mean, we can always type in anything with Tesla. Just show us Tesla. And so it's just showing us that domain right now. We can filter that by the individual entity type. You can do a little bit of analysis here. I showed you a few of the views. But if you want to go analysis to the next level, which is what I want to do, hopefully you do too, we want to scale up. And so let's do that with Elasticsearch. And so just today for NahamCon, we built a feature called a handler, an AWS Elasticsearch handler. And AWS has this really great Elasticsearch service that you don't have to think about much. You can just set up a development system, configure it, give it a name. There's some specifics here. I'll leave these in the slides. I won't spend too much time on them here, but basically you just set up IP-based whitelisting on this one. and create that, and we just wait for it to spin up, and it gives you a URL and a Kibana instance as well, which can be really great for doing analysis. And so if you come in here to handler config and set these send to AWS Elasticsearch settings to the appropriate things, which we've already pre-configured here. So this is going to be the URL. It provides you whatever region you spun it up in, your AWS access keys so that you can push information into it. In fact, you might not even need these if it's whitelisted. You could probably just put anything in there. The way we set it up, or the way we suggested setting it up in the slide, should make these unnecessary. And once that's configured, come here to the project list, select the project you'd like to do more analysis on. Let's just say Yahoo, and let's actually just send to AWS Elasticsearch. And what you'll see is that it starts to push that information directly up to that Elasticsearch instance. It'll take a little bit to upload it. That's fine. We're just doing this on a super small scale right now, just so we can be quick for the demo, and I leave it to an exercise for you at home to play around with. Pull down the Docker container, spin up an Elasticsearch instance. It's all pretty easy. So let's just take a look and see. And in fact, we can see there's information already starting to populate in here. With Elasticsearch, if you're not familiar, you'll want to set up an index pattern. We've already set 2 up. Index patterns are created based on the stuff that's coming in, and so every project will come in with entities and issues. And you can create a new one. If we upload a Tesla, we can just say Tesla, and we may not have any information there yet. It may not even let us create one if there's no information in there. But for our purposes today, we can leave that alone. Come over here, and now we can start to type in anything. Let's give us anything that says Yahoo. And in fact, turn off some of our filters here. Cool. And you can see we get very rich, very detailed information. Things like ports, and we get some aggregations here, which is really nice. Protocols, providers being the network providers. And you can start to filter on these now. It's really handy. So anything on Oath networks. Really Elasticsearch is quite great for this sort of analysis. And so, when we thought about what's the best way to be able to do this, this is a great way. And there's some really, really great calculated fields in here, like cloud hosted, geolocation. Let's actually remove that. And let's add in maybe our ports, scoped, URI. Let's try that. Let's go and remove that. Remove that. And really what we want to see is all the different endpoints. Might need the name to do that. Well, you get the idea. There's lots of power and lots of functionality here. So we hope you had fun with this. Please share. You can effectively, and by the way, there's more information about how to set this up, and some details in here and some examples. But really, thank you all very much for the time. I know we got to go. You can join us in Slack. Just shoot us an email to hello@intrigue.io. If you find this useful, you can find us at Intrigue.io. You can find me at jcran. Feel free to join us in Slack. Just shoot us an email to this, and we'll give you an invite. We'll bring you in. Please use responsibly, and hope you have a great rest of your conference. Thank you very much for the time.